Hi, I'm James, and welcome to my webcast about WebSockets in Decentraland. It's part of the series of Game Jam workshops as a precursor to the Game Jam 2020, and the purpose of my presentation is to run through overall approaches about how WebSockets can be used, to look at some of the use cases, and also to have a look at the setup I'm using in the districts I run. So my approach, I'll just briefly talk through sort of what I'm trying to accomplish. So what I'm trying to actually do with this is to create a pretty scalable and robust infrastructure for real-time messaging. Real-time messaging between users, and also broadcast messaging originating from the server side. So I've been doing a whole bunch of different projects testing out different aspects of WebSockets use in Decentraland. We look at what works, and although my end solution will probably be that a typical scene will probably communicate with a REST server and a WebSocket server, and both fed from the same underlying state database. So with that in mind, I'm not going to be doing anything to do with REST on this, and I may touch on things which are more suited to the use of a REST endpoint, but I'm just focused entirely on here on a scene powered by a WebSocket server. So yeah, some of my background is that I've worked in various sectors, and I've worked in gaming and also in investment banking and FX trading. So I've actually relatively new to WebSockets, but I'm an older timer in terms of socket programming and server side programming using low level network connections. So relatively speaking, WebSockets is fairly straightforward. So there isn't an onus on here in trying to crack technical problems or me showing you the specifics of my implementations. There's already been some really excellent examples. So anyway, let's dive in. So what I'm going to talk about today is largely the pirate ship application, because I'm going to use that as an example, because I think that provides a good end-to-end sort of case of what I'm trying to do. So it exists. I'm going to have my haters, so I'm sure, because I'm running with a Java backend, and I'm using obviously an SDK project on the front end, and I also will create a test harness, which is just basically some noddy JavaScript, jQuery, etc., just to give myself some mechanism outside of the SDK to test the WebSockets. But first of all, let's have a look at the actual big elements of what I'm doing. So I have this Java project, which is the actual WebSockets server, and I have the SDK project here, which is the actual pirate ship scene that is currently deployed in Vegas City, just next to the OpenSea building. So closing some of these tabs, sorry about that. Okay, so SDK projects, it's fairly simple. The pirate ship is basically a GOTF with an animation, and the colliders are also animated. So it effectively, if you jump on it when it's animating, it's going to move you about. So that's the premise of it. It's pretty simple. We've got a pirate ship implementation. It's got methods on it which you'd kind of expect, and you can see here, which is touching on some of the things I'm doing here. So faster, slower, start, stop, set speed, play sound. I think that gives an idea of how this relates to the pirate ship. So ignoring some of these other classes, they're peripheral. the really key one is this class, which is like the handler class for the actual WebSockets messages. So it's really simple, this version, which is why I've actually picked this one. And the essence of it, the important thing, is the onMessage method. This isn't a particularly nice implementation. In a larger project I'm working on, I have like a sort of command, a full command pattern thing going on. But what I'm doing here is illustrating a couple of things. Is that if you notice, when I'm sending WebSockets messages around, and I'm sorry for diving straight into here, but I'm kind of assuming that people are looking at the WebSockets materials out there, so I'm not really going to explain much about how this is working. But the key thing to take away is to have some sort of convention whereby you can have a pattern where every request or every push, every message is going to be of a similar format. So it's very simple what I'm doing here. Everything that comes in, except notifications and sync messages, are commands. So a very ugly if statement, which has grown statement by statement and could be cleaned up and everything else, but it serves the purpose here. So all that's happening is the messages are coming in, and then that instructs the pirate ship what to do in any given thing. So this is really simple. So in the case of going faster, it's literally changing the speed. I'm going in increments of 0.2, and I've also got a set speed method there in case I wanted to go straight there. And that's it in essence. Obviously, when I've got some other handlers here to do with these, they're not really relevant for this example. The crux of this example is really looking at what we're doing on the server. So one of the key things about WebSockets is it's easy to get it up and running locally, and you don't have to use a secure connection if you're running locally, but you have to once you go into production. So you're going to need to get a server with an SSL certificate on it, or something that's going to provide that for you. You can see here I have one large WebSockets server that contains multiple scenes. It happened that I started it on a game called Flamingo Shoot, which is I've been tinkering with for a little while, and so I really need to just rename that. So just in case you're wondering what the heck that was. So really simple stuff. So I'm going to go straight over to the server, and it is a Java server, and I think this is quite useful for the purposes of this, because probably everyone watching this session, most people watching this session, are probably going to be writing their socket server in Node. Obviously, you could also write it in C# or any other language. I happen to prefer Java, not for any particular reason other than I've been doing it longer, and I haven't yet been convinced that something else is doing a better job, all things considered, and part of that consideration is my own proficiency in it. So I also think that Java is a very disciplined language. You can't bend it like you can JavaScript, which is a hindrance sometimes. But on the other hand, if you write a big code base, having something that's very verbose and very regimented, it's a lot easier to come back to something that's very big later on. So the project I was working on before Decentraland, and I'm working full time on Decentraland now. The team had 250 people working for it, and there's probably about 100 developers and about 50 test automation developers. It's a massive project with hundreds of man years worth of code in it, the sprawl was never ending, and one of the things that held it together was I was actually tech like Java, which really enabled a really robust and rigid framework to be built around the code. And in that same environment, we also wrote a lot of C++ servers, and we use Node as well. We use Node for development environments. We used to use React for the GUI, all of the usual stuff. But we never convinced ourselves to move away from these core Java services, which we'd just seen scale to, roll out systems with 100,000 concurrent users. And building something globally which is going to actually scale up, you want to have a game where you're going to have people all around the world competing, and it's going to be fair. It's not going to be like, oh, if you're based in this location you're going to win. It's going to actually be fair. If you invest on a trading system, you expect fair performance. You don't expect that somebody's going to be able to get a better deal because of network latency. That stuff that's long since squeezed out of that industry. And in large scale gaming, the same. So the aspiration of making like a tournament, for example, which is going to be open to everybody without favoritizing people, does mean scaling up to quite a hefty overall infrastructure. And I happen to prefer managing that with something like Java. So one of the things is that, so just to explain the architecture here, and everything else say can translate to every other technology. So I'm happening to use a system called a Spring Boot, and Spring Boot actually enables me to a fast track a Java application. So for people who don't know about this stuff, in fact, it should be Spring Initializer somewhere. Where is it? Sorry, I have to Google it. Spring Boot. So yeah, I kind of like it because you can come here, and this is also built into my IDE as well. You can set your project up, and then you can add dependencies to your project, so it all sets everything up. And so I can add, I can just get like WebSocket dependencies out of the box, which means it doesn't give me any code. And in fact, once you actually open the project, there is no, even though it creates you a WebSocket server application and a WebSockets config file, that's all you get. You don't actually get any WebSocket handler. You have to actually add that in from scratch, but there's lots of tutorials out there. So a Spring Boot application, and this is maybe of interest for Java people who would consider writing a server in Java. This defines the application. This annotation here means this is basically the root of the application, and it has got a main method. So the Spring Boot driver, a library rather, will actually just look for that method, and then that's the entry point. And you can see it's like spawning an instance of itself, which is half constructed by this annotation here. Just to explain another thing, the config for the application is here. So basically, you add your libraries into this file. In the Java world, you have like two really popular build systems, Maven and Gradle. Most people choose Gradle these days because Maven has like XML config, and whereas Gradle uses the Groovy language. And in my case, I had a job as a Groovy programmer for about a year. So for me, it's just it's like far better to work in this. So it's going back to the application. We have a config class, and then this is useful. Like if I was building something in Node.js or any other server that didn't have a really cool framework for managing this stuff, this is the kind of pattern I'd be looking at. So you can see here I've got 4 different WebSockets applications running under here. So I'm registering a socket handler class for each one. I know I'm naughty in this example because I've just set allowed oranges on for the purposes of testing and getting it off the ground. But basically, this can be locked down so that it's only going to accept requests from the Decentraland domain. So we can see here there's my one from the London Underground, which I use to manage that venue. But we're going to go into the pirate ships text handler. Just a couple of bits of explanation here as well. So Spring uses something that's really heavy on dependency injection. So it's about kind of throwing all your stuff together and then letting the framework kind of construct everything on application start, and obviously wire all the dependencies up. So in this case here, I don't need to do any other code other than just auto wire in my pirate ship text handler, and then I'm just adding just adding my actual URLs that we're going to be listening on here. The reason for these is just because of different configurations of running on a local host, and from server to server not having it mounted on the same point. So you can see a couple of other things which I'll move on to, which I think are also key components of a WebSocket server, and one of them is scheduling. So let's get stuck into this. So we'll go to the pirate ship text handler class. So it's basically pretty simple. I've picked this example because it's the simplest one I have, and we can get through this and then maybe add a new feature onto the pirate ship. So there's a reason I'm not actually running the pirate ship visually until towards the end of this, because I'm on my laptop and the fan is already going. So I'm just conscious of not wanting to drown everybody in a noise of laptop fan interference. Sorry. So here we are. So it's basically the key thing here is this handle text message. There's an interface of a socket handler. So if I just actually go through, I can just go back. You can see here that I've extended the text handler. I go back to the abstract WebSocket handler, and if I come all the way to the interface, you can see the real simple stuff. After connection established, handle message, handle transport error, after connection closed, and supports partial message, whether we actually support that. So I go back to our pirate ship handler, and here are the messages that we've overridden. So really simple. When an inbound message comes in, this method gets called. This wraps up the session which made the call, and here's the actual payload. So in the code here, I basically just get the payload and I create a JSON object out of it, and then I am getting the type of a message. And in this case, I'm basically looking at notifications. In fact, I've forgotten sync messages here. Commands and sync, but they're all the same from this purpose. So we just have a broadcast method which basically just iterates through the active sessions and sends a message to each one. So in terms of knowing what the active sessions are, it's not doing that for us. So it's basically we just have a copy on write array list, which is basically a thread safe collection which we can use to maintain session state. So after a connection is established, we just add that user's session. If we wanted to, we could actually do something like send them a welcome message or something like that. And then obviously after their connection is closed, we remove the session. So it's fairly straightforward. So then a broadcast simply becomes iterating through these sessions in that array and sending the message that's been passed in. So really simple stuff. And obviously you could do stuff like if you wanted to just reply to the person who made a request. So if you were just interacting directly with just a one user, you wouldn't iterate. You could just literally send that user back something, or you could iterate through and send everyone else apart from them something. So there's all sorts of things you could do with this. So we have here. I've got a WebSockets helper class as well, which basically is just also a thread-safe implementation of this, because obviously with our single endpoint on a single port, we have to send messages one at a time. So this synchronization here is the thing that allows that to be the case. So it will be 100% reliable. There's not going to be any threading issues or anything like that. So obviously when I send a message, I'm using that helper class, not the socket connection directly. But you can notice that the API for this is very simple. So we've got a bunch of stuff on the session. So there's a few things we could get. So we can build a reasonably sophisticated server handler without having to sort of delve into too much tech. You can see here that I've got some. This isn't relevant to here, but I've got start to weave in game logic and things like that using the socket handler and so on. But for the purpose of this, I'm just limiting everything we do inside this class here. So one of the things that is apparent with Decentraland and WebSockets and in JavaScript in general is that the connection will time out. So what I'm doing here, and in order to stop browser sessions from timing out, you just need to do a one-way sync. It doesn't. Assuming a server doesn't go to sleep if it's idle, but in the case of this, this server will just sit here and then broadcast a sync message, which is basically a keep alive. There's some other things happening on. There's this correlation ID is a mechanism I use, and I'm not using it inside the pirate ship handler, but it's quite hard to secure this stuff in the context of Decentraland. I'm not going to go and talk into my mechanism for securing this stuff, but I think anyone who's kind of probably thinking into this has probably got a fair idea of the sort of approach I might be taking by having a part of the message called a correlation ID. So in the Flamingo game that's coming up soon, which is a simple game which is partially there to kind of put the infrastructure through its paces before getting into sort of more complex games. But it's needed in that to stop certain individuals in the community and outside the community who might want to play havoc with servers. And I know in events so far we've already had unexplained tinkering. I think there was an event in Moonshot. So I think having just something basic, which is going to just make it harder for harder. It's not going to be impossible, but it's definitely going to make it damn difficult. So it's not going to be worth someone's while hacking in. So at a later date, I think probably you have to use a combination of in-world verification so that you know people are actually there. Uh, so anyway, in this framework, I've added my scheduler. It's part of the Spring framework, so I can just schedule this method at a fixed rate of 10,000 milliseconds. So this JSON message here will get broadcast to all users every 10 seconds. It's a pretty crude implementation. I probably, as we scale up, this will get more sophisticated, and the method will be getting called more frequently, and the users will, and the broadcast will be getting sent in batches. However, I don't mind this approach now because the user numbers aren't as high now as we need to be providing for. So actually, I'm clear what my solution is. It's just going to take a bit more code than this. However, this is a good load test for my server and for the infrastructure, because if every 10 seconds I'm sending 30, 40, 50 messages, boom, as fast as I can, that's a bigger hit than if I wrote code to like de-stress the server. De-stressing servers is not what I'm trying to do at this point at the moment. I'm trying to stress them so I can optimize and figure out the best ways to scale. So yes, with that in mind, let's go and have a quick look at another part of this. So let's have some fun. So you can see here I've got a bit of a HTML like JavaScript project going on. It's cobbled together, thrown together with a bit of an example with a jQuery. I've built on that. On my to-do list is to build a nice React version of that, but I'm not going to waste any more time at this point in a time when you can throw it together quickly. So let's have a look at, first of all, the actual pirate ship. So this is deployed live in Vegas City. Need to hide my MetaMask wallet as I can. Not quite. So apologies if my fan starts to go a bit, because as I said I have had to do this on the laptop because of my housing setup, and it being the weekend. I can't be where the kids are doing this demonstration, so I've had to come somewhere quiet with my laptop. So apologies if the fan is something that you can hear. So let's let this load up and I can see what this works. So in essence, I've built a little controller so that I can, because one thing's for sure I've learnt is in-world events are obviously absolutely awesome. Running events and relying on in-world controls isn't always the best idea. So anyway, you can see, oops.
Oh, hi, baby, where have you been?
Right, so this is our pirate ship. And apologies if the music, I just realised that the music might be playing, so I'm going to turn that down a little bit. Or maybe and then the next part of it, this is the currently deployed version. And I've just obviously knocked up a complimentary graphic at the top. But anyway, so this is basically the sort of formula I'm using to run events with, is that I have a sort of growing dashboard that I use to control things with. And then each scene that I make that's controlled by WebSockets, I make myself a little application. At this point, I've just been issuing raw commands. I haven't even had buttons and things like that. But I've knocked this up for the purpose of this demonstration to indicate the commands that I've been sending using WebSockets. So let's have a go. So I'll connect. Send a message. So this is our WebSockets messaging, and you can see here I can start the ship. What I'll actually do is go right in and hit start, and you can see that my SDK project is listening for a particular message to start the ship. And then when it does, it then displays this little score, which actually indicates, sorry, not the score, indicates the number of people connected. So actually, it's not the people on the boat; it's the people who are connected to my WebSocket server. So you can see I've got some things here. I can stop. I can throw myself off in midair. Boom. Well, if I was. Let's try that again. It's a bit slow because of my OBS connection as well. So let's hit stop this time. And you can see it's thrown me off. It's a bit more fun to control when you've not got all of this other stuff running on your machine, because I've been running these events and standing back here with all the avatars on. With not this controller, but the ability to control it, and it's been really good fun. And actually, it's visually shown me exactly, the level of the latency between avatars. Because as I do this, I'm going to start this again. We can watch it. I can speed it up. Which I did sometimes, which is slightly ridiculous, and I can slow it right down. And when you slow it right down, you can converge with a point where everyone's avatars start moving, but you have to get really slow, and then you can see the people with the connections where it is. So over time, the gauntlet is that Decentraland need to make this work. If they improve their engines to the point where you can play an animation where this, as far as the synchronization of the start-start animation goes, the rest of it is going to be relatively true, then it's going to be easy to make multiplayer experiences in Decentraland, using basic tools, and that will be accessible to people. So I'm going to stop the ship, and at the end of that, I can start my audio playing again, because part of this was also to promote the wonderful music that we were lucky enough to have volunteered to us for this project. And this is obviously a console at this point, so I can see what's going on here, and it just gives me the most recent 50 messages. I can clear that. So obviously if I start the ship again, if I actually click the button, you'll see it comes here. But it's so slow that if you want to see it, I'll have to faster. Whoops. So let's stop it. Stop. Anyway, you get the idea. So this is part of my Java application, because obviously the WebSockets app is it's got a web server built in. So I'm just hosting that, and yeah, it's a noddy thing. Even though it looks pretty crappy interface, the reason why I've done it like this was the fastest way that I can possibly have to have it on my mobile phone. So I now have Helm as a web page that it actually fits on my iPhone screen in one, so it literally feels like a remote control for me when I'm so enjoying that. So I'm going to close these windows to preserve my fan, and then we're going to talk about adding a new feature. So what I've been wanting to do is make it so people can come and ride this pirate ship. So there's a few things I will want to do for that, but I'm only going to implement one of them for this for the purpose of this workshop, because I think it's it's easy to get bogged down. I think the implementation is irrelevant really, and watching my Java implementation is only going to be so much help. But hopefully some of these concepts are of use. So what we're going to try and do is make it so this pirate ship is going to run periodically. I'm actually going to give it a bit more life than that. It's not going to be this simple implementation here, but it's along these lines. I'll have it coming alive every so often, and have it do some things. But just for now, what we're going to do is just make it come alive every 2 minutes, so we don't have to wait 5 minutes for it to start. So let's go to our socket text handler. As I've alluded, we have scheduling built in because it's built into the framework, like a lot of other things. So I will just simply do all the good cooks do and get one that they prepared earlier. So here is my start ship method. It's really simple. Create a JSON object just to start the ship. Create another JSON object to send everyone a message, and then broadcast them both. I can do all sorts of other things with this because I can have like fixed delay methods from when I first call the method, and all other things built into this framework. So for example, if I wanted to, I could have, and this is what I'll probably expand on to actually do, is I probably am going to have this scheduled method call a countdown method, which will count down from 30 seconds and indicate to the user that the pirate ship is going to start in 30 seconds. And then obviously this code would then get executed in that method. But for now, we'll just execute this. So one of the things that the scheduled annotation does, and I think it perfectly sums up the features that you would want to be implementing in your own scheduler. So you've got fixed delay, fixed rate, an initial delay, and cron. So cron is obviously you can use to schedule specific times, and then these other delays are useful for other purposes. Like initial delay is an initial like just a pause basically, and then the fixed rate is thinking about the how often, and then the fixed actual delay is specifying a period. So, but for this we're going to use cron, and just to keep it simple, I'm going to go and use this to make our cron expression. So where is it? Here. Right, so let's go in here. So what I always just do before I make a change is just make sure it's working. It looks like it's working. Let's just check by calling up this version of the remote control page. Yep. So go back, kill that, and let's paste this method in. Oh, I lost it. So again, let's have a look at this closer up. So yes, all it is, as I said, those two commands, and then we'll paste our cron expression in, and then we'll compile. So I could actually run this locally, but yeah, no problem. Oh, bit of sorry, the Quant Expressions Springs doesn't support that. Training asterisk. Build again. Okay, cool. So again, we could run that locally. Should we run it locally? Running out of time. Let's dive straight in. Let's not run it locally. Let's actually deploy it. Let me quicker. Send me FTP across. Sorry, guys. Right, bang that across there. I should have continuous integration set up on this really, but I haven't, so should be able to just deploy from Jenkins really, but that will come. I'm going to, what do I need to do? I'll just start and stop the server. So I'm showing all my cards here. I might have okay, so okay, so deployed version. Get rid of those. So did I get that in time? Yeah, I think so. Not convinced I've done that. So I'm going to have to go in again and just double check that. Okay, so let's go back into DCL. Will we get in time? Will we get there in time? We may do. It's 6:59 my time. here we go. Off she goes. We now have an automated pirate ship that runs every 2 minutes. And it will run for obviously the same time, so it's a shared experience. People will come to this, and if they're on the board, then it'll start at the same time for everybody. But if I wanted to, I could still come along here and play havoc with people. This is fun. And I can do it from the convenience of my mobile phone. So let's stop that. And yes, I think that's going to be it for this session.